So here's an example of an exponential model. We've got this piece of art that's initially valued at $150,000 a year. It's got a growth rate of 12%, and we've been given the general formula. So what values, when I have a final model, what values will be replaced by numbers? I want to put little red underlines. When I finish this question, what will have, when I've created my model, what will have values instead of letters? V naught. Yep. So V naught's going to have a letter. A number we probably can already see the number we need to apply for that. And what else will have a letter? A number, sorry, a letter A. So what we're really asking is, can we please find out what our A is? Any ideas?
12%.
It is 12%.
0.12.
Not 0.12. It is 1.12. Now, because we've been given this form, it's nice and easy. We could represent that as V equals $150,000 times 1.12 to the power of T. Much like our compound interest formula. Much like our compound interest formula. But what I want to do is turn this into, instead, I want to put it into this form just to prove it's exactly the same thing. I'm going to get you to sketch both of these to prove that I'm not lying. V equals V naught times e to the power of kt. Same question, but instead of using 1.12, I want to replace k with a letter. So this is my new number. Because e we know is constant. So let's see how we can find this k value. Well, why don't we let t equal 1, which means v is going to equal what? When I say that t equal 1, what am I saying? After 1 year, what's my value? Can we find out our value after 1 year using our calculators? $168,000. I actually didn't need to do this step, but I'm trying to slowly walk you through it. So now I know $168,000 equals 150,000 times e to the power of k times 1. Sweet. What should I attack first here when I'm rearranging? 150,000, so I divide both sides by 168,000. I'm just going to get 1.68 divided by 1.5 equals e to the power of what? K. Happy with what I've done there? Now, this is the learning. How do I get to K? Because what do I want to know? I want to know what K is, correct? So how do I get to K? I need to log. What base should I use when I'm logging both sides? Well, when I wanted to get to before, if I wanted to get to, bad example, but in this scenario I would need to use logs. If it was tech-free, how would I get to that? So if say 3 to the x equals 5, how would I get to the x? I would log base 3 both sides, correct? So if I want to get rid of this e, what should I do to both sides? Log base e. So I'm going to add log base e to both sides. And I get k equals log base e over 1.68 over 1.5. Now the good thing I'm sort of going to reaffirm is that when you're going to use exponential so much that you're going to use this button more than the log you've been previously using. I promise you that. We've got a special button on our calculator. We call log base e, that's the same as ln. It's called the natural log. So we use that a hell of a lot. So what I want you to do is to shove that into your calculator. ln 1.68 divided by 1.5 and see what you get. It's next to log. ln. Yep, and we should get 0.113. Now we have to be very careful we're not rounding too much. Now I wanted to prove, what was the whole purpose of me making you do this? I want you to prove that these two functions are exactly the same. Cool.
What actually is K?
K is a growth constant, or the K constant. So K and B do the same thing. K and B do exactly the same thing.
Is that K just fits in the Euler's?
Yeah, K goes with Euler's number, and I know that right now you're like, this is stupid, why do we have to do this? But it's a bit like the unit circle stuff, where it's like initially it felt, why are we doing this? This is a waste of time, much rather be in degrees. Just trust me when I say, your future maths will prefer that you understand this.
Oh, never mind.
So, to help me prove that these are the same, you actually don't need this part to be the same, right? The first part doesn't need to be the same. I just want you to sketch 1.12 to the power of x and e to the power of 0.1133x and see if they are the same. I'm trying to prove to you that they are the same. And if I'm wrong, I'm sorry, I'll hand my degree back, I've done the wrong thing.